Actually, we need a tripod to do this right, but we're gonna wing it. We finally discovered what was wrong in the program for the orbit simulation. This program originally was written, well, first of all, the program that was written here was not the original program. So somebody, I wonder who, changed it and didn't document it. So when he looks at it, he doesn't know, without a thorough analysis, what the hell he was doing. Okay? But we knew enough that in those days, when this program was written, probably the back in the early 90s, the fastest microprocessor was the 486, the Intel 8486, and we had a speed of 75 megahertz. And so the program worked. I mean, things didn't go zip, zip, zip too fast. Planets were whirling around too fast on this computer. Because now we're talking about from 75 megahertz to 1 gigahertz or more, you know, or I think 2, I don't know what it is on this, 2, between 2 and 3. So what we had to do is go back into the program and put we had to slow it down, okay? And by doing that, things came out normal. So this is an odd way to do it, but let's try it. Let's run the program. And first we're going to start out. Okay. Okay. Watch what you're doing here, Jim. Okay. We're going to put in the normal test parameters. Here we go. I don't know, I think what these parameters are, but as you can see, there's an outer planet and an inner planet. And right in the middle is the sun, of course. The dot right in the exact, well, not in the middle, yeah, exactly in the middle of the black box. And the inner planet's in an elliptical orbit, but it's not stable. Why is it not stable? Because it's being perturbed by the outer planet, which has a certain mass. Okay? But it seems to be stable enough. I mean, it's stable, it's chaotic. We would call this a chaotic orbit, but it's stable within what is called the attractor. It seems to constantly vary, but it always stays within the donut. And there's probably no chance of it ever coming out. Welcome to chaos theory. Okay. Now let's do something different. Okay. Now we're just going to show you an extreme condition of what happens when okay. Come on, focus here, guy. Okay, when we put a big, huge mass on A, let's put about 15. Okay. And Jack's initial velocity is 0.6. Okay, here we go. Now watch what happens. See, the outer planet's got enough mass that's perturbing it. And it perturbed it enough that it sent it towards the sun, and the sun ejected it from the solar system. So are you beginning to see something here? The solar system was quite finely tuned for all the planets to be so precisely in orbit. They're not precise. Over millions and millions of years, they're unstable. But, and eventually, something's going to get ejected, like maybe Mercury. But, for now, we're alright. It's stable over our lifetimes, or over civilization's lifetimes. Okay. Let's try something else. Let's see here. Okay. Well, let's put about the same thing for the year. Now I'm going to do something different here. We're going to put in a mass of 7 that's not quite as big as what we had before. And we're going to see what happens. Are you ready? Here we go. Okay. Notice the mass on the outer planet makes the inner planet very unstable. Okay. Let's see what happens. It looks like we're going to be alright, doesn't it? But wait till the outer planet and the inner planet line up or get close to each other. Okay? And watch what happens. Uh-oh. We're starting to run into problems. Uh-oh. Whoops. It's going to go around the sun. Whoops. Back up to the outer planet. Whoops. Slingshot around back towards the sun. And the sun ejects it from the solar system. So much for orbital mechanics. So, we're going to get a tripod. We can do some more playing with this so I can operate the keys better. But we'll upload this to give you an idea of how... one more thing. Let's try to circularize the inner planet's orbit. We can do that. Okay. I don't know if I was successful at it, but we will try. No, we don't want to do that. No. Okay. 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 Mass of A. I will make it 0 for now. Okay. And let's put in a value of 0.5 and see what happens. See if that circularizes the orbit. Not quite. That's not going to do it. It's stable because the outer planet doesn't exist. We gave it a mass of 0. So basically we have the inner planet in a very stable orbit around the sun. Elliptical orbit. Okay? Alright. Okay. So, one more time. I'm going to pour on this forever. Okay. What the hell? I can't save it. Oh, okay. Okay. Okay, 0 again. And velocity, what do we put in? 5. Let's put in 0.4 and see what happens. We still got an elliptical orbit. In fact, we have a more elliptical orbit. One more time. We'll put in a faster one. See, this is the fun of orbital mechanics. Okay. We'll put in 0.8. See what happens. Here we go. Now we're getting close. See? We're getting very close to a circular orbit. The reason why is because the inner orbit's velocity, or initial velocity, is higher. So, we'll try it once more. See if we can circularize it completely. Start. I think we put in, let's see, let's put in 0.9 this time. Not completely, but we're getting there, you know. Still elliptical, but as we fine-tune it, we could get to a circular orbit. Now, it's not quite circular, it's a little more the other way, so it's fine-tuned, very fine-tuned. You know, all these other solar systems are flying around other stars. None of them are stable. The planets are too massive, too close into their star, or one thing or another. I don't think they found one that's exactly, I don't think they ever will find one that's exactly like the solar system. And now I want to tell you something. That ought to tell you something. Think about it. Now, does that mean that God tweaked knobs while the solar system was being formed? No, because he's an infinite being. And all he had to do was, we can't even grasp it. At the Big Bang itself, everything was programmed in, so to speak. That someday a galaxy would form, and a solar system would form, where the planets would be perfectly stable for life to develop. All programmed in at the Big Bang. It may be there wasn't initial conditions like we're setting here. Maybe just the laws of physics themselves. We're getting way out now. But we're talking about an infinite creator that we can't, our minds can't grasp it because we have finite minds. But it was designed, yes. But was it designed like the creationists? No. God didn't have to. He doesn't have to do things the way we think he does. He does them. He's an infinite in his being. And he can do things beyond what we can't even think of. Alright? Alright.